Welcome to JC Connect. Yesterday we were discussing about the workability test. In that workability test, there are three methods are there. The first one is a slump test. Second one is a compaction factor test. The third one is a web test. For the slump test, maybe yesterday itself I have explained it. How to conduct the slump value and all those things. And of course it is not suitable for very wet and very dry conditions. If it is a wet, normally it will start flowing. So if it is dry, normally it will not it will not come down in the in the cylinder, so that it should be consistent mix. And I have already said that how to mix the concrete with a standard procedure. So mixing is also very important when you are conducting the slump test. And you have to use this IS code, that is IS 7320 1974, for complete design of this slump cone, and the complete mix design for various mixes. For example, if you are conducting the slump test for M20 concrete, slightly different procedure is there. If you are conducting the slump test for M30, complete procedure is there. So based on the mix, you have to find out it. So then the next test is compaction factor test. So of course it is used to determine the workability of the concrete. And in this experiment, we are find outing the compaction factor. So that compaction factor is nothing but it is the weight of the partially compacted concrete to the fully compacted concrete. So means in this experiment, two conditions are very important. First, that is partially compacted means normally we can call it as a self compaction. Then second one is weight of the fully compaction means we with the external force we are making it to fully compact. So for this procedure, what we are doing is we are using different apparatus here. The first apparatus is the hopper bottom polished surface, which is hinged at the bottom. That you can call it as the first one, hopper bottom bucket. You can call it as a hopper bottom bucket at the first one, which is little bit the height will be more. The second one is a cylindrical mold, which is at the bottom. And in the middle you can see that it is also a hopper bottom, having slightly lesser height compared to the first one. You can see from the top to the bottom, the first one is that is also hopper bottom bucket is there. Hopper bottom bucket is there, so which is a little bit more height. The second one is that is also hopper bottom, slightly less height is there. Then the last one is a cylindrical shape. So then what you can do is that you prepare one M concrete or any one of the mix, and start pouring on the first bucket from the top. So normally what you can do is that um, um, whatever the top bucket is there, you close it at the bottom. So then fill it. Once it is completely filled it, make sure that it is not fully compacted it is just pouring it, not fully compacting. And immediately you release the bottom portion. So then it will start flowing into the um, second bucket. So when it is start flowing into the second bucket, uh, make sure that it is also not fully compacted. So then allow it to come to the bottom portion of the cylinder. So there also we are not making any fully compaction. So then take the weight of there is a free fall, we can call it as a free fall. Then take the weight of the cylinder, whatever the bottom cylinder, along with the concrete. Before that you have to take the empty weight of the concrete, empty weight of that cylinder, whatever the bottom cylinder is there. Then with the self compaction take the weight. So then this is the first one, you keep it aside. So then at this when the second time when you are doing it, again what you can do, one more set of concrete you can take it, you can pour it on the first bucket, or let it free fall. Then again you compact it using the rods. Here we are compacting it, it's a fully compaction. Then mm, make it allow to come to the bottom portion. Then we have to compact it at the top two buckets only. Then whatever the compacted concrete is there, let it come down to the bottom cylinder. Then what will happen is that take the weight of that also with a fully compacted concrete. The difference, the excess concrete whatever it is there, you weigh it and record it. So then calculate the compaction factor uh, using, initially you will calculate how much weight of the concrete is coming down, coming with the self compaction, and how much weight of the concrete is coming when it is fully compacted. The ratio is nothing but compaction factor. So normally zero point 0.8 is the better value for this compaction factor test. Make sure that when you are doing compaction factor test, um, the concrete should be well mixed, and some of the standard protocols you should follow uh, with the water to binder ratio of 0.45, that is fixed, that fixed value you have to follow it. Otherwise what will happen is that if you are adding more water, so normally the compaction will not going to happen, you won't get the correct compaction factor. And most of the time the compaction factor uh, uh, will it, it is going to equal to 1, it should not happen. And for this we can use the IS code of 5515 1983 version, and the wave test. So it is used to find out the workability of the concrete. So of course it is not suitable for the higher workability. um, so normally the slump above 75 we can call it as the higher workability. So then it is suitable for the concrete with very low workability. It is not suitable with very low workability, and not suitable with high workability, which is the slump values greater than 75 mm. So then the apparatus which you'll use it here, that is VB meter. Normally this wave test is, we can call it as a VB meter. um, so then it consists of vibrating table. On the right hand side you can see that the vibrating table is there at the bottom, and which is supported with um, vibrating platform. Then above that you can see that one cylinder is there. Then above that you can call it as a golden color uh, hopper bottom metal cone, which is opened at both the ends. So then it is a iron rod, and the right hand side you can call it as a glass disc. So normally what we'll do is that we'll take the concrete, and we will pour it on the metal cone opened at both the ends, and we will pour it. So then with the help of the rod we will compact it, means with the help of the vibrating machines or with the help of the rod we will vibrate it so that it has to be well settled. So then we'll move to the disc onto the cone, and we will touch the top surface of the concrete uh, top surface of the concrete cone with help of the disk, and that disk consists of the graduations. That also we will record it. So then I already said that your metal cone is opened at both ends. Then what you can do is slowly vertically you lift that cone. Then once you vertically lift that cone, you can you should you should see that um, whatever the concrete is there inside that cone, it should shape with that cone only. Sometimes if water to binder ratio, if it is increased normally, um, you cannot see that kind of structure. So then what you can do is that immediately um, you remove the bottom plate of that top plate of that whatever the cylinder is there. Then once you slowly it will settle in the cylinder. Once it is going to settle, start the vibrating. um, then start the stop clock also. And then once start vibrating it and start the stopwatch. So then stop the vibrating when your concrete is going to become horizontal. Note down that time. Whatever the time is there, that time is nothing but that is the VB seconds. That we can call it as a VB seconds. That itself is your workability value. For in detail explanation of this, what you can do is that you can refer um, this code BS, or you can use IS code also. IS code is also there. You can use 12350 or 2009. Of course, for the next type of um, experiments, we will take it in the next class. Thank you.